All right, so graphing rational functions. Your domain for these is always going to be all real numbers except, and it's going to be numbers except what makes the denominator 0. So here I would set the x plus 3 equal to 0. So I would get x equals negative 3. So my domain is going to be all real numbers except negative 3. Your vertical asymptote is going to be that number. So x equals negative 3. So I have a vertical asymptote at x equals negative 3. So your asymptote is like a line that your graph is just not going to cross. It's going to get super duper close. Now to figure out your horizontal asymptote, you have to look at your numerator and the denominator. So if the degree in the numerator is bigger than the degree in the denominator, there's going to be no horizontal asymptote. So something like x to the 7th plus blah 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 over x to the 5th plus blah blah blah. If the numerator is less than the denominator, then your horizontal asymptote is always y equals 0. So if I had x to the 5th over x to the 7th. If your numerator is equal to the degree of the denominator, you're going to take the leading coefficients. So if this was b over x to the 4th over a over x to the 4th, you take these numbers in front. And that would be your horizontal asymptote. So here I have an x to the 1st and an x to the 1st. So these are the same. So I'm going to take the numbers in front. So my horizontal asymptote is at y equals 1. Now, to get our graph, we need to make a table. So we're going to pick numbers to the left of our vertical asymptote. So to the left of negative 3 would be negative 4, negative 5, negative 6. And then we're going to pick numbers to the right of our vertical asymptote. So to the right of negative 3 would be negative 2, negative 1, and 0. And then we're going to plug it into this equation. So when I plug in negative 4 over negative 4 plus 3, that'd be negative 4 over negative 1, which would be positive 4. Plug in negative 5, so negative 5 over negative 5 plus 3. That would be negative 5 over negative 2, so that'd be 2.5, and so on and so forth. You don't have to write out all of the work if you want. You can stick it in your calculator. Just make sure you put your numerator in a parenthesis and your denominator in a parenthesis. All right, so our other numbers we should get are 2. So let's do this left half first. So I plot these points. So the point negative 4, 4, negative 5, 2.5, and negative 6, 2. So when I connect these points, I cannot cross my asymptotes, so I just get really, really close. You kind of follow the lines, or the directions of your vertical asymptotes and your horizontal. So we do the same thing with the right side. So when we plug in negative 2, so this would be negative 2 divided by negative 2 plus 3. So this should give us negative 2. When I plug in negative 1, that'd be negative 1 divided by negative 1 plus 3, which is 2. So this would be negative 0.5. And when we plug in 0, 0 divided by 3 is 0. So we plot these points. And connect them. And don't cross your asymptotes. All right, 2. Your domain is all real numbers except numbers that make your denominator equal 0. So I set my denominator of x plus 2 equal to 0. So I get x equals negative 2. So my domain is all real numbers except negative 2. So my vertical asymptote is at x equals negative 2. To get my horizontal asymptote, I look at the degrees. Here, the denominator is bigger than the numerator. So the numerator is less than the denominator. Whenever that happens, it's always y equals 0. Whenever I have a bigger x exponent on the denominator. To get my table, I'm going to pick numbers to the left of my vertical asymptote. So to the left of negative 2 would be negative 3, negative 4, and negative 5. Then I'm going to pick numbers to the right of our vertical asymptote. So that would be negative 1, 0, and 1. And then you're going to plug these values in for x. Here we only have an x on the denominator, So it's going to be 3 divided by each time. So this will be 3 divided by negative 3 plus 2. A negative 3 plus 2 is negative 1, so 3 divided by negative 1 is negative 3. And then you just plug all these points in. So I'm going to pause the video, try them, make sure you can do it. Okay, so you should get negative 1.5 and negative 1 when you plug these in. So then you plot them. So negative 3, negative 3, negative 4, negative 1.5, negative 5, negative 1. Do the same thing with the right side. So plug those in. So we should get 3, 1.5, and 1. It won't always be the exact same or the negative versions of it, just like in the first one. All right, and then you connect them. And there's your graph. So on 3, your domain is all real numbers except numbers that make your denominator equal 0. So x minus 1 equals 0. I need to factor this. So this is a difference of squares. It factors into an x plus 1 and an x minus 1. So I get x equals negative 1 and x equals positive 1. So that means I have 2 vertical asymptotes. I have one at negative 1 and I have one at positive 1. For your horizontal asymptote here, the denominator has a bigger degree. Whenever there's a bigger x on the bottom, it is always y equals 0. And now notice I have 2 vertical asymptotes, so this means I'm going to have a left to the left of my vertical asymptotes, to the right, and in the middle. And I don't know why I have extra boxes here. You really only need 3. All right, so if I pick numbers to the left of my vertical asymptotes, so to the left of the left, this would be negative 2, negative 3, negative 4. If I pick numbers to the right, I would pick positive 2, positive 3, and positive 4. And if I pick ones between, I need 3 points between these, and since there's only one pretty point, I'm going to have to do negative 0.5, 0, and positive 0.5. So when we plug this in, we just have to be careful. So example, if I'm plugging in negative 2, I'll have negative 2 over negative 2 squared minus 1. So this is negative 2 over 4 minus 1, which is negative 2 over 3. So negative 2/3. Or if you like decimals, you would have gotten negative 0.67. All right, so if you want to try these, go ahead and pause it. If not, I'm going to do them real quick and then write them in. All right, so these are the points that we get. So when we plot these, I'm going to be a little bit harder to plot, but they're going to look something like this. They're getting closer and closer to this 0. This is basically telling us that this graph is in this quadrant. Oop, that should have been, these should have all been negatives. So it would be down here. And then the right side, it is positive. And in the middle, it's going to look something like this. Now notice that it's crossing our horizontal asymptote once in the middle. That is okay. So now you might have some questions about this, and it's just probably because you don't remember how to factor. So I'm going to do a couple factoring problems for you, just to jog your memory. All right. So I did one of each type. There's not one of all of these on your worksheet, but just to be safe. Number 1 is a greatest common factor, GCF, because 5 and x can go into both of these. So we factor out a 5x, and we're left with x plus 5. If we were finding where this equaled 0, we'd set both of our terms equal to 0 and solve. So we'd get x equals 0 and x equals negative 5. 2 is a difference of squares. So it's where you take the square roots, one's plus and one's minus. So this would be x plus 7 and x minus 7. And again, if we were solving for 0, you'd set each of your parentheses. Trinomials where a equals 1 is a factor sum. So I'm finding factors of 12 that have a sum of negative 7. So two numbers that multiply to 12 and add to negative 7 would be negative 3 and negative 4. So this would factor into an x minus 3 and an x minus 4. And a trinomial where a does not equal 1 is SAM. And I don't think there's any SAMs on the worksheet that you're working on. So here we have to multiply 2 times negative 4, so we're finding factors of negative 8 that have a sum of negative 7. Those two numbers should be negative 8 and positive 1. So because there's a 2 in front, it'd be a 2x minus 8 and a 2x plus 1. And because we multiplied, we have to reduce, so we can reduce this one by 2. And there's our factoring. All right, hope this helped.